Hey everyone, it's Coding with Kareem. In our last couple of videos, we looked at how we can use Go routines, mutexes, and wait groups to make our code more concurrent, but I did mention that we probably want to move away from using a mutex and use a channel instead. So essentially a channel is just a mailbox to where one Go routine can kind of pass in a value and another Go routine can kind of retrieve that value. It's kind of meant as a replacement for a mutex and a way to synchronize Go routines. And there are a couple of problems with using a mutex, and I kind of want to elaborate on that. So in this file, we have a mutex declared on line 12, and then we're using this mutex from line 47 to 49 to protect this API data map. One issue using a mutex is that it kind of forces you to keep track what parts of your code are being accessed by multiple threads. When you have a small file or small code base, that's really not a big deal. It's easy to track. However, as your code base grows, that can be very hard to manage, especially when you have variables that are being declared by value, being declared by reference. If a variable is being passed in by reference, meaning it's the same memory address, if you have multiple threads writing to that address, you'll cause race conditions. If it's a fresh copy, a different memory address, you won't have that problem. However, in a big code base, you have so many different function calls. You have variables being declared all over the place, some in certain methods, some globally. So that can just be very, very hard to manage. Channels kind of remove the need for that, and you don't really need a mutex to be able to pass data around and synchronize Go routines. So we're going to remove the need for using a mutex in this file and just use a mutex. The first thing I'll do is I'll just declare a channel. And for this channel, we actually need a type. So I know that for API data, for me to add data into it, I need a key and a value, both being of type string. So I'm going to make a struct kind of representing that. I'll just call it data. And we only really need two fields. So I'll say key, value, and they'll both be of type string. So I'm going to make this channel. And for now, I'll have it be unbuffered. And I'll make another video elaborating on the differences between buffered and unbuffered. Next up is we don't really need this mutex anymore. We don't want it, it's ugly. We're going to remove that mutex and we're going to remove the code relying on this mutex. Instead of kind of locking a mutex and then running to this API data, we're going to directly use a channel. So what I'll do is I'll send data to this channel. I'm going to init the struct that we just made, so data, and I'll pass in the URL and I'll pass in the result. Next up is we actually want to process that channel and the data that we're getting in our main function. And we really want to synchronize the essentially the blocking of this wait group with closing the channel. We want that to kind of happen at the same time. So whenever all of our Go routines are done doing their work, that's also when our channel should end. So I'm going to make another Go function or a Go routine. I'll have it be anonymous. And in this function, I'll just do wait, and then I'll close the channel. So whenever our Go routines are done doing their work, we're also going to close the channel. Now I'll call this anonymous function. We also don't need a line anymore on line 25. Next up, let's actually iterate through our channel. So I'll say for result range channel. And just a note, whenever you kind of do this, whenever you loop through a channel or iterate through a channel, this is blocking. This will run forever until the channel is closed. So until line 27 happens. That's kind of why we're combining this wait call with closing of the channel. And that's why we're also doing it in a separate Go routine, because if we didn't, we wouldn't really be able to process any data that we're getting from the channel. So now that we have the data that is being kind of passed into the channel, here you go, it's the result of type data. We can actually populate our API data map with the value from result. So I'll say API data, I'll have the key be result.key, and then I'll have the value be result.value. And that's essentially it. So if you guys look, we no longer are using a mutex and we're purely using a channel. So in our fetch function, we're actually passing in the data, so the URL and the result into this channel. In our main function, we're iterating through the channel, and whenever we get a result, we are populating our API data map. So let's actually run this file and see what we get. And as you guys see, we get a key with a valid value, this being the URL of our target server endpoint, and then we get the value, which is our stringified version of our array. This is precisely what we got in our last video as well. So that's essentially it. I just wanted to show how we can use a channel to kind of remove the need of using a mutex. I hope you guys learned something. And in our next video, I'll probably cover a little bit more on the differences between using a buffered or unbuffered channel. Right now, we're using a unbuffered channel, but we can also, add a buffer to this channel. So we can actually just add a capacity. And if I run this code, we'll get the exact same thing, and it'll actually be slightly more efficient. But that'll be for a different video. I hope everybody has a great day, and goodbye.